Hello everyone and welcome to Coding Card. So previously we have solved this problem Palindrome linked list with four methods you can see here with the help of string, stack, list and two pointer in the last session. So here in today's session we will be solving with the help of two pointer concept along with one list data structure. So so you can see here previously we have solved with the help of two pointers in which we were reaching to the midpoint and we were simply reversing the half of the linked list and we were comparing one by one. So for example, suppose we are having one linked list having value 1, 2, 2, 2, 2, and suppose 1. Suppose this is a linked list having even number of nodes. So with the help of two pointer concept, what we did was we were reaching at the midpoint and we were simply reversing the half of the linked list. So after reversal, the linked list was looking like 1, 2, and 2. So this was one linked list and this was one linked list after reversal. So after reversal, what we did was we were comparing node by node value in linked list 1 and linked list 2, node by node value. If they were equal, then we were returning true, otherwise we were returning false. So here in this session, we are not going to reverse the half link. So what we will do here is, let me explain you here. Suppose we are having a linked list, the same linked list. So here we have even number of nodes in this linked list. Here we will take one list. Suppose here we are taking one list, and what we will do here is we will use the same concept, two pointer concept p1 and p2. This will be my slow pointer which will move one node at a time, and this will move two node at a time. This will be my fast pointer. So with the help of fast pointer we will reach the end of the linked list, and with the slow pointer we will reach at the midpoint. So when we are reaching to the midpoint, when we are going node by node, we will add that node value in our list. And when we reach the middle part, what we will do? We will start comparing from the array values. For example, here when we are moving to the half part, my array will be having value 1, 2, and 2. And this is my midpoint. So next will be here. I will be staying here. And what we will do, we will compare from the end in the linked list. If they are equal, then we will move forward. And here we will go in backward direction in the array. If again they are equal, we will move forward and we'll compare the array value by going backward direction. Here again both are equal, we will move forward. Here the linked list is over. If it is over, then what we'll simply see if all the values were equal, the half part values were equal, we'll simply return true. Otherwise, we'll simply return false. So same concept. Here we are not going to reverse. Here we are using one extra data structure list to save the half of the node values, so that whenever we are moving the half part, we are simply going to compare with the list values one by one from the end. So let me explain you again one more time with the odd number and the even number of nodes in a linked list. So suppose we are having even number of nodes having value 1, 2, 2, 2, 2 and 1. So this is my P1, this is my P2 and this is my suppose array. Now here P1 will move one node at a time and P2 is moving two node at a time. So whenever we are standing at any node, we will simply keep that value in our array. So we keep here 1. Let us move forward. P1 will be here and P2 will be here. Now we are standing at 2. So let us keep here value 2. Now let us move forward. And this will move two node at a time. So it will come here. Now this is my P1 and this is P2. So we are standing here, we will keep here 2. Now this is my half part of the linked list. So here we have to apply a logic for the even number of nodes while P2 dot next is not none. P2 dot next is not none, then we are going to move forward. Otherwise, we'll stop there. Because whenever this condition is satisfied, it means P1 is at the midpoint. Means we reach the half of the linked list. So we'll stop here. Now see here. After this, what we will do, P2 work is done. P2 work is done. P2 work is done. P1 was standing here. So whenever this condition is done, while loop is over, P1 will move here. P1 will move to this next node. Now we are standing here. Now what we will do, we will compare the node value with the array value from the backward direction. Now see here, the node value p1.val. Let me erase this. Let me delete this one. We will compare p1.val equal to array of I. Suppose I is currently -1. We are starting from here. We are starting from the end, so -1. Now see, the values are equal. We will move forward. P1 will move forward. Let me write here I equal to -1, the initialized value. Now we were here. After moving forward, when the values are equal, this this pointer will also move in the backward direction. Simply I value will be changed, I equal to I -1, so that I will move backward direction. Now we are standing to the next node. Now again here the value is 2 and here the value is 2. Both are equal. Let us move forward. P1 will move forward, and here this pointer will also move in the backward direction. Again both the values are equal, 1 and 1. Both are equal. Again P1 will move forward. P1 will move forward. Now P1 value is here none. So whenever it is null, we will simply execute from the while loop. So here all the values were equal, so we'll simply return true. Otherwise, we'll simply return false. So this was the condition for the even number of nodes in a while condition. Now what we have to write for the odd number of nodes. So let me explain you here. Suppose we have odd number of nodes, 1, 2, 2, 3, 2, 2 and 1. Now this is my mid part, correct? So P1 will move one node at a time, P1, P2 will move two node at a time. Again P1 will move one node, P2 will move two node. P1 will move one node, P2 will move two node. Now see here, P1 is at its correct position. Here P1 is at its correct position, means at the middle part, and P2 is here. So to stop this P2 iteration, so here for the odd number of nodes, our condition will be while P2 dot next, P2 dot next is not none. Then we will simply stop. And here you can see, here, suppose this is our array. Now when we were moving node by node, we'll keep here value 1, 2, 2 and 3. Currently P1 is staying at the middle node. So we have kept all the values. Now let me delete this all. Now P1 was here. So after keeping this value, P1 will move to its next node here. Now see, for the odd number of nodes, we have only here at the end, we have only half linked list, which is 2, 2 and 1. But whenever we are getting odd number of nodes, we are having our one extra value, the middle node value at the end of my list. So here I will start my I with -2, so that we can easily compare the P1 dot value with the minus index here. -2 will be from here. Correct. So for odd number of nodes, we are going to initialize I with -2, so that P1 is here. We will simply compare this value. If both are equal, we will move forward. Both are equal, we are going to move forward. P1 will come here and this pointer will come here. Again both are equal. Let us move forward. This will come here and P1 will come here. Again both are equal. The values 1 and 1 both are equal. P1 will go here and it will come, this pointer will come here. Now P1 is none, so it will simply break. The next while loop will break. Since all the values are equal, we will simply return true, otherwise we will return false. So for odd number of nodes, this is our condition in while loop to iterate till the end. And to iterate in the array, we are going to initialize the I with -2. So this is the concept. So let me write the code so that it will be more clear. So this was our previous logic. Here we have used the reversal logic in half of the linked list. Now here, let me zoom this one. Now here what we have to do here is we have to take two pointers, P1 equal to P2 equal to the head. Okay, so P1 is the slow pointer, P2 is the fast pointer. Now, so let us write one while loop to iterate in the linked list. So here P2 is the one which is going to the end of the linked list. So here we will write the condition for both odd number of nodes and even number of nodes. So for odd number of nodes, we have here for odd number, we are checking by P2.next is not none. And for the even, we were checking P2.next is not none. So let me write both the condition here. So while P2.next is not none. This is for the odd number of nodes in the linked list. And at the same time, we are going to check if there is a even number of nodes then. And P2.next is not none. Is not none. Then what we are going to do here is, here we will take one array, empty array, and let us take one I value, and default value is -1. Okay, we will check one condition. If the number of nodes is odd, then we will change this I to -2. Now what we are going to do here is we'll simply append array dot append p1.val. So we are going to move one by one node in p1 and we are adding in the array. And let us move forward. P1 equal to P1.next and P2 equal to P2.next. It is moving two node at a time. Whenever this P2 reaches the end condition, we are done, means at that time P1 has reached to its mid part. So after this, what we will do, after this we will add that mid value in our linked list, means array dot append p1.val, means the last node value on which p1 is standing, and p1 will move forward and p1 equal to p1.next. It means, let me explain you here. Suppose this is my linked list 1 2 2 2 2 and 1. So p1 is moving one node at a time, p2, this is p1, this is p2, p1 p2. So p1 is standing here, and this is the condition for the even number of nodes. So even number of nodes condition is p2.next is not none. Here it is none, so it will simply come out of the while loop. So we have to add this value in our array on which p1 is standing, and p1 will move forward. P1 will move forward so that we will get the half of the linked list like 2, 2 and 1, and p1 is standing here, so that we can easily compare this value with the array value like 1, 2 and 2 from here in backward direction. So that's why here we are writing array.append p1.val, means the value on which p1 is standing, and p1 you move forward to the next node. Now we got the half of the value in a list, and p1 is standing on the very first node of the half of the linked list. Now here we will write one if condition just to check whether my number of nodes were even or odd, so that I can initialize the I value with -2 if there is odd number of nodes. Like here I have explained you this one. Like here I explained you, if there is odd number of nodes, you don't have to focus on this last element, the middle element. We have to focus from the next one, so that my I value should be -2. So here we will check if for the odd, the condition is p2.next. So we'll check here if p2.next is none. If it is none, then my I should be -2, correct? Otherwise, my I should be by default -1, means there is even number of nodes. Now we will write one while condition. Now I think this is clear to you why we are initializing with -2, as I have explained you here. For the odd number, our condition check is this to reach the end. If this is the condition means there is odd number of nodes, then we have to start from the -2 position from the array so that we can compare easily from here. Now let us write one while loop just to compare the half of the linked list with the array values from the end. Now while now P1 is standing at the very first node of the half of the linked list. So while P1 is not none. So P1 will be moving one node at a time, and we are going to check if P1.val not equal to array of I. Now here we are checking the P1 value, means the node value on which P1 is standing with the array last element. If they are not equal, it means if they are not equal, then we have to return false. If they are not equal, then we will simply return false. Okay. And if they are equal, then P1 will simply move forward. P1 equal to P1 dot next, and at the same time I will also move in backward direction. I minus equal to 1. I will be decreased by 1. So this while loop will execute till P1 reaches the end, and node by node it is checking the value in the array from the backward direction. If any of the value is not equal, then it will simply return false. And if this while loop is over and we haven't returned false, it means all the values were equal. So by default we are going to return here. So by default here we are going to return true. So we are done. This is the logic. So let us run this code. So you can see here it is working. So let us submit this code. So you can see here it got accepted. So I have explained you this problem, this palindrome linked list with the help of 5 solutions. First one was the very easy one with the help of string, then with the help of stack, then list, then using two pointer concept, and then using two pointer along with the list. In two pointers, we were reversing the half of the linked list, and in this two pointer with the list, we were not reversing half of the linked list, but what we are doing, we are simply saving the half of the linked list in the array, and for half of the list, we were simply comparing the value from the end in the list. So I hope you understood each and every solution in a very easy manner. So if you have learned something new, please hit the like button and subscribe to our channel Coding Card, and stay connected for the next problem. Thanks for watching.